The Rational Zero Theorem. Our objective for this video, we want to use the Rational Zero Theorem to find possible rational zeros. Let's remind ourselves that rational numbers are any numbers that can be written as a fraction. Okay, what do we know that we're going to need for this lesson? We need to know what a polynomial function is. In particular, we want to notice the leading coefficient, because we're going to use the leading coefficient, and we want to notice the constant term. Okay, and we know that a polynomial which has the powers going from greatest to least is written in standard form. And we also know that the degree of the polynomial is equal to the number of zeros. We've been focused more on calling them zeros, but they're also called solutions or roots. Okay, the rational number theorem. When finding zeros of polynomial functions, these zeros can be real numbers, which means they're rational or irrational. Okay, remind ourselves that real numbers appear on the number line. Or the zeros can be imaginary. They don't appear on the x-axis. Okay, I restate that here. As we know, real number solutions, show up on the graph as x-intercepts. Imaginary solutions do not show up as x-intercepts. Okay, so let's take a look at how this might work. A sixth degree polynomial has been factored as follows. Let's remind ourselves that a sixth degree polynomial has 6 solutions if multiple solutions are counted separately. Multiple is 6 zeros. Well, in this case, all the zeros are different. This 0 is -3. This 0 is +1/2. This 0 is -√2. This 0 is +√2. This 0 is an imaginary 4 minus 5i. And this 0 is the imaginary 0, 4 plus 5i. Okay, we have 6 zeros, and they can be a combination of real and imaginary or non-real. In this case, I have all kinds of zeros in here. Okay, these two are rational. They can be written as fractions. These two are irrational. They cannot be written as fractions. And these two are imaginary. Okay? This group are real zeros, which means they are on the number line. They are on the x-axis. And we'll call these our non-real, although I prefer to use imaginary, but we'll call those our non-real zeros. They are not on the x-axis. Okay, so what is the Rational Zero Theorem? Okay, it's a tool. It can be used to make a list of all possible rational zeros of a polynomial, as long as a polynomial has coefficients that are all integers. It's kind of specific. So it doesn't help you with these. Doesn't help you with these. It only helps you with the ones that are rational, and it requires that your polynomial functions have integer coefficients. Okay, not every number in the list will be a 0, but every rational zero will be in the list. And finally, let's recognize that some polynomial functions have no real solutions, so no rational solutions, because they're real. Their only solutions are imaginary. This is kind of specific. It's kind of particular. Okay. What does the rational number theorem tell us? Okay, how does it work? If a polynomial function has, there we go, integer coefficients, all possible rational zeros must be of the form P over Q in simplest form, where P is a factor of the constant term, which is a sub 0, and Q is a factor of the leading coefficient, which is a sub n. So your possible rational zeros are your factors of the constant term over the factors of the leading coefficient. Okay? Let's take a look. So, this is my constant term. Its factors are plus or minus 1 and plus or minus 3. Negative 3 can only be factored as 1 times 3. Obviously, positive 1 times negative 3, negative 1 times positive 3. This is my leading coefficient. Okay, this is 4. Its factors are positive and negative 1, positive and negative 2, and positive and negative 4. For example, negative 1 times negative 4 is positive 4. Positive 1 times positive 4 is positive 4. Okay, so what are my possible rational zeros? Possible rational, forgot the I, zeros. Okay, they're equal to the factors of the constant term, positive negative 1, positive negative 3, divided by the factors of the leading coefficient, positive or negative 1, positive or negative 2, positive or negative 4. Okay? Now let's do all this. I'll start with the 1 and I'll put it over those 3. So this is equal to positive or negative 1 over positive or negative 1. This numerator over this denominator. Positive, or negative 1 over positive or negative 2. This numerator over this denominator. Positive or negative 1 over positive or negative 4. This numerator over this denominator. Now I've exhausted the 1. Now let's spread the 3 out. Positive or negative 3 over positive or negative 1. Positive or negative 3 over positive or negative 2. And positive or negative 3 over positive or negative 4. Okay, let me come up a little bit here so we can make sure I don't lose you. Okay, let's simplify all this. Well, this is simply plus or minus 1. This is plus or minus 1/2. This is plus or minus 1/4. This is plus or minus 3. This is plus or minus 3/2. And this is plus or minus 3/4. Okay, so 2, 4, 6, 8, 10, 12. I have a total of 12 possible rational zeros. Okay, now, this is a 5th degree polynomial, so they're not all zeros because I only have 5 zeros. I have 5 zeros. But if I have any rational zeros, it will be in this list. Okay, if I have any rational zeros, it will be here. Let's take a look at our graph and see if I have any rational zeros and which one I have. So I'll turn this on. I'll go to my y equals and I'll put in my function, which is 4x to the 5th plus 12x to the 4th minus x minus 3. And I'll make sure I'm in the standard window. Okay. Looks like I have 3. Looks like I have 3 rational zeros here. I have 3 zeros. I have three real number zeros. So I guess I have two zeros that are imaginary, but I have 3 real number zeros. Let's see which of these is on the list. I'm going to check the one on the left first. So second calc, a 0. And I'm going to go over to the left side of that 0, which is below the x-axis. Let me get over there a second. Here I come back down, maybe. Okay, I lost myself. Let's see where I got to. 1, 2. Somehow, I'm not able to see my cursor. I don't know why. I guess I'm skipping ahead too much. Well, left bound is there, and there's that left bound. Right bound is over there. Okay, I found the bounds, and they're in between those two lines, and I'll take a guess. And -3 is a 0 right there. So, -3. Ding, 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 I have a winner. -3. Let's see if these two are rational. So second calc, a 0. Okay, I gotta get over. Okay, that's good. And then get beneath it, and that's good. And okay, nope. -0.70701, that's too many digits. It's obviously rounding something, so that is not a rational 0 there. And let's go to the other side. And let's see here. Is this one? Let's see. This one is positive 0.70710. Nope, that's also been rounded. So it turns out I only have one rational 0. Okay, it's -3. So the actual rational 0 is -3. So as it turned out, I had 12 possibilities, but the only one that actually was a rational 0 was -3. But it's on the list. If it's a rational 0, it will be in this list. Let's take a look at a second example. Okay, list all possible rational zeros of this 4th degree polynomial, -x to the 4th plus 3x squared minus 4. And then we're going to graph it to see which are rational zeros. Okay, well, here is my constant term. Its factors are plus or minus 1, plus or minus 2, and plus or minus 4. Here is my leading coefficient. It's a -1. Its factors are simply plus or minus 1. Okay, so possible rational zeros are going to be, well, my numerator is the factors of the constant term. So plus or minus 1, plus or minus 2, plus or minus 4. My denominator is factors of the leading coefficient. That's simply plus or minus 1. And again, I'm simply going to just spread this out. So plus or minus 1 over plus or minus 1. So this 1 goes to that 1. I'm done. Let's go to the 2. Plus or minus 2 over plus or minus 1. Plus or minus 4 over plus or minus 1. So I can simplify this. I have 6. If I have a rational 0, it is one of these 6. Positive or -1, positive or -2, positive or -4. So total of 6 possible rational zeros. Okay, let's see if any of these, it may have none of them. If there's a rational one, it's one of those 6. Okay, let's take a look at this graph. And I'll go back to my y equals, and I'll put in this function, which is -x to the 4th plus 3x squared minus 4. I think I'm in the standard, but I'll check, and here it is. And guess what? I don't have any real zeros at all. This graph is entirely beneath the x-axis, so I have no real zeros. It's a 4th degree polynomial, which means that all 4 of my solutions are imaginary. Kind of unique, but I have no real, which means I have no rational. So these are the ones that I could have had, but it turns out I have no rational zeros. So actual rational zeros? None. None of those at all. So there you have it. It's simply the factors of the constant term divided by the factors of the leading coefficient.